Hello everyone, myself Sravanthi, working as an assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today my topic is activation record. Here I am going to discuss what is activation record and how the activation record is created and what is the structure of these activation record with examples. And we are also discussing activation tree of this one. So what is activation record? So activation record is nothing but in a program when a function call is done. So when a function call is done, one activation record will be created. Nothing but a procedure or a activation record will be created in the stack memory. So there are different types of storage allocations are there here. So in that storage allocations in the stack, when a function call is done, the activation record will be created over the stack. So here, what is this activation record? So suppose see here when a function call is done. Here let us take this is one example. This is one example. When a main is done, main is nothing but it is a function call. A function call is known when it have open and closed brackets. So when a main is called, nothing but it is a function. So in the stack, this will be stored in the stack. It will be stored as main. It will be stored in the main function is stored in the stack. So nothing but one activation record is created for the main, and then internally the main function is having one more function call, that is nothing but a function. So again a activation record is created. Again in a function call there is b is also created. B activation record is created. Nothing but for every function call there will be one activation record will be created, and these activation record will be popped when the execution of that function is completed. When the execution of that function definition is completed, that function or that activation record will be popped from the stack. So when a is called, again a function call, a function definition, there is b function call. So b activation record is created. Again for b there is the definition of b is having a c function call. So c is going to be created. Now this c function is going to be executed. Nothing but the definition of the c will be executed. Once the activation record execution is done or completed, it is popped from the stack. So when a function call is done, nothing but the activation record is pushed onto the stack, and when the completion of that activation record will be popped from the stack. So first the C function call will be executed, nothing but the C will be popped from the stack. When this completes its definition, its execution of that one, then the next one will be B will be executed. Once the B execution is done, the B will be popped from the stack, and then next A will be popped from the stack. The next A execution is completed, then main will be popped from the stack. So nothing but here when a function call is done, one activation record or one procedure is created in the stack, and that will be popped when it is completed. See here, information needed by a single execution of a procedure is managed using contiguous block of memory. So what does it mean? See here, this is my memory, the storage memory allocations. I am going to have here static, and the next stack is there, and the next I am having heap is there. So here in the stack memory allocation, the procedure calls are going to be created. Nothing but here the activation record is created. So let us take here, suppose this C execution, the C function call is created inside this one stack. In the stack, the activation record is created. So the definition of nothing but here all the statements, what are the static memory allocations are there, all these things are created in the stack in a contiguous memory allocation. Nothing but block of memory is given here. So nothing but here somewhere some space is left there one statement, and somewhere the memory is left there one statement, it will not be there. So here the whole program execution will be allotted a contiguous memory of allocation. There the program will be executed in the stack. There the program will be stored in the stack. So that is nothing but it is managed using a contiguous block of memory. Nothing but the storage is allocated contiguously. An activation record is allocated when a procedure is entered, and deallocated when a procedure is exited. So nothing but when a function call is done, that activation record is created in the stack, nothing but pushed into the stack, and when activation record is completed, it is popped out from the stack. Nothing but it is deleted from the stack. A size of each field can be determined at compile time. Here the stack is nothing but here it is a static, the memory is allocated, the size is allocated for each definition or each function procedure. The memory is allocated at compile time only, not at runtime. So the structure of the activation record. Here I am telling the stack is having. So to store in the stack, there are 7 steps are there where the steps will be executed. So this is the structure of the activation record. This is the structure of the activation record. So in this activation record, there are 7 steps are there to complete the activation record. To complete the activation record, there are 7 steps are there here to complete. Nothing but this is the structure of the activation record. This is the structure of the activation record. The activation record is placed in the stack. So procedure is called is nothing but it is stored in the stack. So here in the stack, we are going to have all these 7 steps are going to be there here in the structure of the activation record. So first one, what is the return address? So before going further, this is these steps or these return values, parameters or control link, access link, all these can be placed in any direction and nothing but in any places it can be placed. This is not the fixed one, refers return value parameters. It can be placed in any way. The return value can be somewhere and access link can be somewhere. So that is the return. These are the structure of the activation record. So the first one, return address. So what is the return address? So when I'm writing a program, when I'm having a program, let us take one example of this program. So here void main and some program I have written over here. So what it happens here in the stack? What happens it in the stack? So a main is called here. Main, as it is a function call, the activation record or a procedure is created in the stack. So it is created in the stack. So the next one what I'm having is return values is there. So what is the return value doing? When a program is called, see here first the void main is there. It enters into the program and it is open braces and the next x equal to add of 10 comma 20 is there. So what type of it is? It is nothing but it is a function call. So whenever I see this function call, it jumps to the function definition. It is a function call. So then it is going to be created a procedure in the stack. So it directly jumps from this one to the definition of that add function. So here the definition is going to be executed. So the definition is going to be executed into C equal to A plus B and return C. So what it is going to do? It is going to calculate some values. 10 is assigned, 20 is assigned to it, and it is going to be calculating C value. Nothing but some 30 will be the answer. So this value is written back to the X. So this value is written back to the 6. So nothing but the return is nothing but what it does is nothing but it is returning some value from the definition to the main function, nothing but the calling function. So that is nothing but the return values. When it is returning something, the definition or the activation record will be popped. Nothing but this execution is completed and these will be popped from the stack. See here, the memory location to which control returns after the function execution is called return address or return values. Here I have completed the execution of these add function and then I'm returning the value 30 to the main function. So nothing but x equal to 30 is assigned. So when I am completing these execution is nothing but when I see these closed braces, so nothing but this activation record is completed, this execution is completed. So nothing but here in the stack the add function will be popped, nothing but the procedure will be popped. So that is nothing but the memory location to which control returns after the function execution. So the next one we are having is parameters. So what type of parameters we have? There are 2 types of parameters we have: actual parameters and formal parameters. Actual parameters and formal parameters. What is actual parameters? So the actual parameters is nothing but that lies in the function call. In the function call, whatever the values will be there, whatever the data type we are going to declare, so those are nothing but the actual parameters. The formal parameters are nothing but in the definition, whatever we are calling, so that is nothing but the formal parameters. So in the definition of a function call, in the definition of that function, the variables or whatever we are going to place in that brackets, so those are nothing but the formal parameters, and the actual parameters are nothing but in the function call we are passing some values we are going to pass. Those values we are calling it as actual parameters. See here the 10, 20 are the values. I am going to pass these 10, 20 values to the definition add int a comma b. See here a comma b are nothing but the formal parameters. 10 comma 20 are the actual parameters. Next, So the next one we are having is control link and access link. I'll let you tell. So the next one is local data. So local data is nothing but in a definition, in a function call or in a definition, whatever the variables that are there. So those variables are fixed into that definition only. When I complete the execution of these definition, the variables will also be reallocated. So nothing but it will be popped from the stack. See here, I have written here add function. Let me write once again add function is called here. So what are the variables I have? A comma B are the variables are there. So these are the variables of this definition. A comma B comma C are the local variables in this definition, and these variables are created in the add procedure. And C, A comma B values are nothing but 10 comma 20 values are allocated. Why? Because from the actual parameters we are going to get the values 10, 20, and C is going to get some garbage value until I do calculation. Just I have declared int C. So C is having the data type integer and it occupies 4 bytes of memory, and the value it is allocated is garbage value initially. So now the value of C equal to A plus B will be calculated here, and it returns the value to the main function. So that is the procedure here it is happening. So what are the local variables we are having? A, B, C are the local variables that are declared inside this add function. When I complete the execution of these add function, so these variables will also be deleted. Nothing but it will be popped. Again, these variables are not live. So to do for the main function, to go for to execute in the main function, if I declare here A plus B, so these values are not known here until and unless I declare and I initialize the values to it. So local variables are local or fixed only to that particular definition. Local variables store variables declared within that function. So global variables can be used in overall the whole program, but the local variables are used within that particular function. Here the local variables A, B, C are used only within the add definition or add function. Here X variable can be used in only the main function. So the next one is temporary variables. So what is temporary variables? So temporary variables are nothing but here. I want to do some calculation here. C equal to A plus B into some D. A plus B into D. Let us declare here C comma D equal to some 5. D equal to 5. I need to calculate C equal to A plus B into B into D. So I need to calculate or I need to solve these expressions. To do these type of expressions, as the 3 address code will have only 3 variables should be there, and in the RHS side we should have only one operator. But here I'm having 2 operators. So I'm converting these B into D. First in these A plus B into D, first I need to calculate B into D, and then these values should be added to the A, and then I should store it in the C. So let me assign this B into D with some temporary variables. If based on the given expression, I'm going to allocate the temporary variables to it. So now B into D, for this one I have given T1 as a temporary variable, and this B into D, B is nothing but 20 into D is nothing but 5. So 100 is assigned to T1 variable. Now T1 A plus T1, A plus T1, A is nothing but 10 plus 100 will be calculated, and it will be giving 110 the value to the C. So this is nothing but the temporary variables. So based on the expression, we are going to create the temporary variables like T1, T2, so on. So here the temporary variables stores intermediate values or temporary results in it. So based on the given expression, to understand the 3 address code, the 3 address code actually it should have the 3 statements should be there, 3 variables, and in the RHS side we should have only one operator should be there. If more than that we are going to apply or we are going to use the temporary variables, and we are going to store the results in it. So the next one is saved machine status. So what saved machine status will be there? So let me take once again start. So let me discuss here the same thing once again here. So this is my main program. When main program is, it is a function call. So activation record is created in the stack, and the next one I am having open brace. The next X equal to add 10 comma 20. So it is a function call. So it just checks for the definition. So I'm having the definition over here, and this program will be executed. After executing this definition, where it will return. So this will return to the next statement, that is nothing but the printf statement. So what? Let me assign some values over here, some numbering 1, 2, 3, 4, 5. and some definition I'm allotting it with some different values 20, 21, 22, 23, 24 and 25. So now after this x equal to add 10 comma 20, it is going for the definition of that program. After executing this definition, where the cursor should go, next which line I should execute. So that is nothing but after this statement execution, which statement is there for me? Fourth statement, that is nothing but printf. I have assigned with some number, that is 4. So after the third statement, after the definition execution, so the next statement it should execute is nothing but the fourth statement will be executed. So what I'm going to tell here, we are going to save the machine status. So after executing this definition, so the next statement it should execute is nothing but the number 4 line should be executed. So that is nothing but saved machine status. See here, the field for several machine status holds information about the state machine before the procedure is called. Nothing but we can also call these saved machine statements as PC, or we can also call it as program counter. So before the execution is completed, only we can allot the next line. Nothing but next which line will be executed in the procedure or in the activation record. So that one we are saving here. So that we are going to call it as saved machine status, or we can also call it as program counter. So the next one we are having is control link and access link. So let us look after one example for control link and access link. So consider some chain function here. So main A1, A2, A21, A1. So this is some chain function I'm taking, and this is the execution of that one. So how these will be stored in the access link and control link. So let me take, this is my, so the first one will be executing is A1, next A21, A2, A1, main. So this is the procedure I have written in the stack. So here first I am writing here access link, how the access link is working and how the control link is working. So let us look here. What is the access link? Used to access non-local data of another activation record. So what we are going to do here, the access link will access the non-local data of the another activation record. We are going to store, or we are going to access the another activation records data we are going to access here. So see here, so access link I have written. So the next one is control link is there. So here the first one we are having is the main A function is there. So this A function call is called in which function? In which function we are going to call this A function? So let me check here A1 where I have called in this program. In which definition this A1 function is called. So this A1 function is called, let me see here. This is one definition, this is one program, and this is one definition. This is one definition, and this is one definition. So the main is having internally A1 function call. There is A2 function is calling, and in the A2 definition one function call is there in that A1 function call. So this is one definition, and this is one definition, and there are 4 definitions in this program. So now this A1 function call is done in which definition? In which definition it is done here? So this A1 function call, so it is there in the main function. In the main function call, it is going to be done, main. Next, A21 function call. So A21 is called where? So here A2 is called in A1. Here A21 it is a definition. Here A21 is called in from which function call, from which definition we are going to call? Using A2 definition we are going to call it. So the next one A2. So A2 is called here by using the A1. A2 is called by using the A1. A2 is called by using the A1. So the next one again A1. A1 is called, again A1 is called by using the main function. Now main is called with what? Main is called, so with no function we are going to call this main. So nothing but we are going to call it as, we are going to write it as null. So the access link is nothing but, so the function calls is done in which definition? In which definition we are going to call this A1 function call, or A21 or A2 or A1 or main? So in which definition we are going to call this function calls? In another activation record. So we are going to call in another activation record, non-local data in another activation record is going to call as access link. So the next one is control link. So in these in control link, so what we are going to have points to the activation record of the caller function. So it is going to point to the caller function, nothing but the previous function we are going to call here in this control link. So in the control link, what we are having here, so A1 is there. So A1, in the A1 definition, which function call we are going to have? In the A1 definition, which function call we are going to have? So nothing but A2 is there. A1 function call, A1 definition, A2 is the function call I have called. So the next one is A21. In the A21, I have A1 function call. And in A2 we have A21. A21. So in the next A1, I have A2 function call. In the main function, which one I am calling here? In the main function, I am going to call in the main definition, I am having A1 function call. In the main definition, I am having A1 function call. So in the control link, we are going to call nothing but in the definition. In the definition, which function call we are going to call? Caller function. So nothing but in control link, we are going to use the caller function, previous function we are going to call. And in the access link, in the definition, in this definition, this function call is called in which function? In which definition this A1 function call is done? So that is nothing but access link. The control link is nothing but in that definition, what is the caller function we are going to write? That is nothing but the control link. In the definition, what is the control function? What is the caller function? And in access link is nothing but that definition is called, that calling function is done in which definition? That calling function is done in which definition? Which activation record? Definition is nothing but in which activation record we are going to call. So that is nothing but access link. So these control link and access link are optional. These links are optional. So this is nothing but the structure of the activation record. So the return values, it returns the value from the definition to the calling function. Parameters are nothing but actual parameters are there, formal parameters are there. Actual parameters are nothing but these values are passed from the calling function to the definition. So that is nothing but the parameters. Control link, access link, just now we have seen. And machine status is nothing but before we execute the next statement in that activation record, the next which statement will be executed. So we are going to save that number, that is nothing but saved machine status. We can also call it as program counter. Local data is nothing but in that particular definition or in that particular activation record, what are the variables are there that are active in that within that function only. So that is nothing but the local variables. And temporaries are nothing but we are going to create intermediate variables or temporary variables to store the results when in order to execute the complex expression. So these are nothing but the structure of the activation record. So all these steps are done inside the stack only. Inside the stack memory allocation we are going to run. Why? Because when a function is called, an activation record is going to be created in the stack. So to do these these are the steps that takes place in order to execute a program or in order to complete one activation record. So the next one we are having is activation tree. So what is an activation tree? So we are going to show it in a visual representation. That is nothing but how the control is flowing from one function call to the another function call, and how it is going to be executed and how it is popped from the stack. In activation tree, each node presents an activation or a procedure. When A is called, nothing but it is a function call. So nothing but one activation record is going to be created in the stack. One activation record is going to be created in the stack. We can also call it as activation record or a procedure for that record. The root represents the activation of the main program. So main program, this is my main program. Then this is my main program, and I'm going to have this will be my main will be my root program. So the next A is going to be created. The node A is the parent of the node B. if the control flows from A to B. So again, if I'm having A definition, and again in that B is the function call. If that is the case, A node is the parent, and B is the child for the node A parent. So nothing but if the control flows from A to B. The node A is left to the node B if the lifetime of A occurs the lifetime of B. So what does it mean? So see here in the stack, main is created. First in the main, I am having in the main, and the next A is going to be there. In the main function activation record, I am going to have A function call. So A function call is created and it directly jumps to the definition of A, and in that definition I am having B. B function call is going to be created. Now B definition is going to be executed. So what this statement is telling? So this A lifetime will be there until I complete this B program. Until this B execution is completed, till then this A will be active. Why? Because once the B is popped, then only A can be executed. So A is left to the node B if the lifetime of A occurs before the lifetime of B. So once the B is completed, after then only I can execute the A. So A is left till before the lifetime of B is completed. So let us see one example by using the quicksort. So quicksort int m comma n I equal partition and quicksort. So what does it mean? So this is my main program, nothing but this is my root program, root. So here I have said each node represents an activation or a procedure. The root represents the activation of the main program. This is my main program. So what here I am going to do here is nothing but, so read array is there, and then next again what I am going to have here, quicksort. So this is in the main program I am having, some read array and quicksort. So it comes here quicksort, and here in this quicksort I am having partition, and the next one is quicksort, and the next one is quicksort is there. So again to call this one quicksort, it goes to the main self definition recursion, it is going to happen. So nothing but again partition is going to be created, again quicksort, and again quicksort is created. Again next this partition is going to be called, again this will be executed. So until the given values completes, until the elements are in sorted order. So until then this will be created. So this is the activation tree for this one. So see here, so activation record, read array. So when a main is called in the stack, main function is created. Nothing but the activation record for main is created. Then afterwards I am having read array. So read array is a activation record. It is pushed into the stack. So the next one I am having is quicksort. So what does quicksort is having? Quicksort is having again the partition is there. Quicksort is having the partition is there, and again in the partition again what I am having here. So the next partition is there. So here the partition is going to be done here. So the partition is going to be done. The next what we'll be having here, quicksort 1, 4 and 6, 4. All these will be created over here. So when this is popped off, the next 1, n is going to be created, and the next 1, 4 will be created. So how it is happening? Main is nothing but main is created here, and the next read array is created. And the next one is we are having is, so this read array execution is going to be completed. Then afterwards the next statement I am going to have is quicksort. So this is popped, and the next one is quicksort is played. So I am having pain, and the next one is quicksort is going to be created, quicksort of 1, n, and the next one I am having is partition is going to be pushed into the stack, and the next, so partition will be executed, partition definition will be executed, then it is popped up from the stack. Then the leftover I am having is main quicksort 1, n. So the next statement I am having is quicksort 1, 4. To execute this 1, 4, again I have partition 1, n, QS 1, 2, quicksort 1, 2, and quicksort 1, 4. So nothing but what it will be, main quicksort 1, n. So now quicksort 1, 4 will be executed. Nothing but what it is going to be created. Again partition is going to be created. Now this is completed. The next quicksort 1, 2, and after completing this again partition. So in this way it is pushed into the stack, and once it is completed, it is popped out from the stack. So in this way the activation tree is looking here. So when a function call is done, nothing but a procedure is going to be created in the stack, and once the activation record or the procedure is completed, the activation record will be popped out from the stack. So that whole things are going to be done or allocated in the stack memory allocation. So this is about the activation record. So till now what we have discussed is what is the activation record and what are the steps that are going to be takes place in a stack when an activation record is pushed into the stack. There are 7 steps are there: return values, what are return values, and what is a parameter, what is a local data, and what are the saved machine status, what is access link, what is control link, and what are the temporary variables. All those things are going to be stored in the activation record. So then after that activation record will be popped once the execution is completed, or once the program is completed, all the activation records will be popped out from the stack. Here in these activation record, the memory will be allocated contiguously, not like a one in somewhere space is left in the stack, there one statement and other way somewhere statement. So that is not going to be done here. It is allocates contiguous block of memory will be allocated here. So this is nothing but the activation record. In the activation record, the main program will be the root node, and the next one, if A is calling some B function and then B is executed, until then the A lifetime will be there. So this is about the activation record. Thank you.